Welcome to Module 16 of the Documentation of Contract Quantities course. We're still in the Documentation Guide, Section B, and we will be talking about items that are paid by the ton. Here we can see on page B3 the tonnage columns where we have our pay items. We'll talk about agricultural ground limestone, aggregate base course, and HMA surface course adjustments. Accuracy of measurements to the nearest tenth of a ton daily. Required documentation, weight tickets, daily summaries, Department of Agriculture scale decals because these are paid by weight, independent truck weight checks, inspector at the scale if we don't have an automatic ticket printer, and possibly daily tare weights where required. On page A25, the bottom of page 25, top of page A26, is the procedure for the aggregate moisture correction. This correction is for type A stone that has a moisture requirement for compaction. Here we will show you an example next on page F41, but to correct the scale weight for a type A aggregate based on moisture, you're going to collect a sample of the material and check the actual moisture content of your materials. So we get a weight of the sample when it's wet. We dry it in an oven per the manual of test procedures. We get a dry weight of the sample, and we take the wet weight minus the dry weight divided by the dry weight, typically in grams, and that will give us a decimal percent of moisture. The pay weight is then our scale weight, or our tickets, times 1 plus the allowable moisture, whatever it is by spec. A lot of times this is 6%. Divided by 1 plus the actual moisture. So we get the actual moisture decimal percent here. 1 plus that number is what we divide by. This will equal our pay weight in tons. Please note, actual moisture content test should be rounded to the nearest tenth of a percent in accordance with the manual of test procedures for materials. On page F41 in the doc guide, we have an example of running a ticket tape for aggregate base course type A. Here we have our date, our pay item number, pay item description, our location, our contract number, and here's our clear on our adding machine tape. We're adding up all the individual ticket weights. We get our total pounds. Divide by 2,000 to get tons. We get 273.65 tons. That was the actual weight of material that was placed on the job site. We took a representative sample to calculate our actual moisture content. So we take the wet weight minus the dry weight divided by the dry weight, and that gave us a decimal percent of 0.072 or 7.2% moisture content. The specification for this material was 6%, so our calculation is our ticket weights times 1 plus the requirement, 1.06, divided by 1 plus the actual, all right, so 1.072. We do the math. We get a final pay quantity of 270.6 tons. We are paying less than the actual ticket weights because the actual moisture content was greater than our requirement. So there was excess water. We're not going to pay for the excess water. As we've said before, if we had less than 500 tons per day of aggregates delivered, we do not have to perform this aggregate moisture correction. However, we do reserve the right to always perform this correction. Next topic is agricultural ground limestone. You can follow along on page A26 in your doc guide. Here we have the discussion of agricultural ground limestone. We'll show you an example on page F42 in the doc guide shortly. In accordance with Article 250.09, the pay weight for this item is to be adjusted using a source correction factor for the source of the agricultural limestone. The correction factors are stored in the MISTIC system and available upon request from the district materials engineer. You can also get these source correction factors from the Department of Agriculture limestone booklet. The adjusted pay weight will be calculated as follows. Adjusted pay weight equals the actual ticket weights divided by the 4-year source correction factor. This correction factor is normalizing your source of agricultural limestone to a standard. That standard produces a certain effect. This 4-year source correction factor is adjusting for sources that have better effect or less effect, more effect or less effect. If you're using an agricultural ground limestone that is more potent than the baseline effect, it would take less. Therefore, we give a little bit of bonus to the contractor for bringing us material that has more effect that we want. Therefore, you could actually pay more than the ticket weights based on that correction factor. I know it's a little counterintuitive, but that's just the way it is with agricultural ground limestone. Here in the 2022 spec book, page 111, we have the article on agricultural ground limestone. It's measured by weight in tons, having an effective neutralizing value of 67.5. Don't worry about this one. That's what is used to compare each different source. A 4-year base source correction factor of 1. That's what this is. So you're going to measure, the producers are going to measure their source and relate it back to this one to come up with their 4-year source correction factor. The pay quantity will be the applied quantity, or my weight tickets, divided by the source correction factor. Here, that's what you just saw. On the Department of Agriculture website, you can find a copy of the limestone booklet. You can also reach it through the Illinois Department of Transportation website. This is a shot of the first page of that 2019 limestone producer information. Here we have the county, we have the different producers, they have an IDOT number, where it's located, and some other calculations that we don't need to be too worried about. IDOT uses this 4-year correction factor. So this is the one we're going to use. Here we've got one that's greater than 1, right? If you remember, the pay weight will be the weight tickets divided by this factor. So if we're dividing by something greater than 1, that means this material is not up to the same standard as our benchmark. It is less potent than our benchmark we're looking for. However, the next two that you look at have source correction factors that are less than 1, meaning it takes less material of these. Here, this one as well, 0.88, takes less material than the baseline to achieve the same desired effect. So if we had a pay weight divided by something less than 1, we're actually going to increase the actual pay quantity to the contractor based on a better performing product. On page F42 in the dot guide, we have another Inspector's Daily Report, IDR. Here we have our agricultural ground limestone pay item number. We have our description. The location was the entire job, or 10 acres. Down here, the plans required 4 tons per acre to be applied to 20 acres. The 4-year conversion factor from the existing limestone booklet was 0.85, our 4-year source conversion factor. Total tons that were required were 4 tons per acre times 20 acres times 0.85. That's my source correction factor. I'm going to need less of this potent material than actual plan quantity, right? Because I would need 4 times 20 would be 80 tons, but because it's more potent times 0.85, I only need to spread 68 tons to achieve the desired effect. The actual tons delivered and spread were 71.0 tons. See the tickets, right, where we added them up. So the pay quantity is the delivered amount divided by our 4-year source conversion factor. So 71 tons divided by 0.85 means we would pay a quantity of 83.5 tons for this application, right? We got 71, but because it was more potent, we actually got more effect. So what we're doing, and by paying for more tons, is actually paying for more effect. This is a better product. Don't forget, paid by weight, we have to assess our max pay. Our planned quantity, 4 times 20, would have been 80 tons. If we look on page A15 in the dot guide, for our max payment percentage, it is 1.08 or 108%. The maximum we could pay is 86.4 tons. We calculated 83.5 we're going to pay. Since this is for the entire job, we'll pay the lower amount of max pay versus the delivered amount. We're going to use delivered. 83.5 tons was our delivered amount. All right, you can follow along in the spec book on page 213. This is hot mix asphalt, or HMA, surface course adjust plan quantity, we're making an adjustment for our surface course mixtures only. We previously talked about theoretical quantities for HMA binder. Now we're going to extend that to surface courses. Our surface courses change density based on the type of aggregate that we use. We use different hardness and friction characteristics of our aggregates. Sometimes we use steel slag, sometimes we use some trap rock or granite, depending on what type of mixture we're making, and that can change the density. When we're calculating our theoreticals, we need the density of the mixture to come up with our theoretical tons. So we want an accurate density. Here's the method for achieving the actual density of the mix. The adjusted planned quantity in tons will be C, a correction factor, times the quantity shown on the plans or as specified by the engineer. So if we make some calculations and we have a revised planned quantity, we would want to use the most accurate number, right? The most accurate plan or theoretical quantity times this correction factor to come up with the actual tonnage that we need. Here's the correction factor. C is equal to GMB, which is the average bulk specific gravity from the approved mix design, or sometimes referred to as little d. From the approved mix design, not the daily plant reports. You'll get an approved mix design. It will have this average GMB value. That is the one we want to use, not the one that changes on a daily basis based on the job mix formula. So we got our bulk specific gravity times a constant to change our units, 46.8. Those units are down here. We're converting from a density that is in pounds per square yard inch. We want to end up unitless, so we have to convert for the weight of water. We've got square yards to square feet, and we've got feet to inches. That comes out to 46.8. It doesn't change as long as we're using the English units of pounds, feet, inches, square yards, square feet, and tons. U is the unit weight of the surface course mixture shown on the plans in the units of pounds per square yard per inch used to estimate planned quantity. Likely this U number is going to be 112 pounds per square yard inch, but please check your plans or contract special provisions to see what number the designer used for estimating planned quantity. So what we're really doing is coming up with the actual density of the mix divided by the assumed or estimated density, and we're going to have a factor that will adjust us back to the actual density from our plan calculations. On appendix page 93, you can see an example of a bituminous mix record or an approved mix design. Right here we have the mix properties. We've got our GMM and our GMB. Right? The number we're looking for is this GMB category. That's our bulk specific gravity. We want it out to 3 decimal places, 2.340. We got to have that third decimal place. GMM is the maximum theoretical specific gravity. That is not the value we are going to use. This would be the value if we had the mix and had absolutely no air. Zero air voids would give us the GMM value. If we had a solid block of this mix with no air voids, it would have this density. However, we do have air voids in our actual pavement. That's what we have for our GMB value. So use the mix design, GMB value, approved mix design only. Here we go. How do we adjust the planned quantity? When the planned quantity is accurate, right? We didn't change it with measurements. We only have planned quantity. We have the GMB or little d from the mix design of 2.320. The planned quantity is 1,200 tons. We have to calculate our C factor. So we have our GMB, 2.320, times our constant of 46.8. Our plans told us that the designer assumed 112 pounds per square yard inch. We calculate the C factor. We get 0.969. This is an extremely important point. This C factor must also have 3 numbers after the decimal place. Take it out 3 places. If you truncate this one or round it, you will be highly inaccurate and you will not get the correct number. Therefore, the adjusted planned quantity will be our C factor times our planned quantity, 1,200, results in 1,162.8 tons. This is the new theoretical or adjusted planned quantity. If we were to look at max payment, we would take our most accurate planned quantity number times the max pay percent, which we can find where? You're good. Page A15 of the doc guide, that's correct. 103% for HMA materials. That would give us a maximum payment amount of 1,197.7 tons. What happens when planned quantity changes? We've made actual measurements out in the field, or we've changed the scope for some reason. We're going to calculate one, a new theoretical tonnage. We've seen that equation before. Two, we're going to calculate the adjustment using the C factor. That's what we just looked at a moment ago. Three, we'll calculate the max pay so we can evaluate at the end of our pay atom. Let's look at an example. Here on page Workbook 22, we have the HMA surface course example as specified by the engineer. 1. Calculate the new theoretical tonnage. We had a planned tonnage of 229 tons. We had a planned length of 1,022 feet, a width of 24, and a planned mat thickness of 1.5 inches. As specified by the engineer means measured in the field, we had an actual length of 1,027.5 feet, so a little bit longer than the actual plan. Width is the same, 24 feet, and we're still going to put down 1.5 inches. Our equation for the theoretical tonnage, right? We use this binder theoretical tonnage equation. We're still going to use that. We have our thickness in inches, 1.5, our width in feet, 24, our length in feet, 1,027.5, that's the actual measured length. Here's our density term, 112 pounds per square yard per inch. We have to convert to get the tons. All right, so we're converting our square feet and square yards. So we have 9 times 2,000 pounds per ton results in 230.2 tons. You can go ahead and verify that math if you want. You can pause the video if you need to. Continuing on, page 23 in the workbook, we're on step 2. We've calculated our theoretical tonnage as specified by the engineer. Now we need to calculate our adjustment based on its surface course, its actual density. The bulk specific gravity, or GMB, from our mix design is 2.370, right? 3 decimal places. The assumed density, or the U term in our C factor equation, is 112 pounds per square yard inch. We've got our unit conversion constant, 46.8. So we have our GMB times our constant divided by our assumed density from the designer. We come up with a C factor of 0.990. Okay, watch that third decimal place. So our adjusted quantity based on the surface course actual density is 0.990, our C factor, times our new theoretical of 230.2 tons. We come up with an adjusted planned quantity, or an adjusted theoretical, 227.9 tons. Last, we can calculate our max pay based on our theoretical. Max pay for HMA items, 103%. So we take our most accurate adjusted planned quantity times our max pay percent. We would only be able to pay up to 234.7 tons at the end of the job. All right, your turn. Workbook page 24. Here we have HMA surface max pay problem. You're given the GMB, or little d, from the approved mix design. We measured the length of the paving, the width of the paving. Here's the planned thickness of the mat. The contractor has delivered 2,310 tons. The question to you, is the contractor exceeding the maximum payment quantity if this is all we had for this contract? So go ahead, pause the video, work this problem, and we'll talk about the answer here in a moment. On workbook page 41, we have the answer to our HMA surface max pay. First thing we need to do is take our field measurements and convert that into a theoretical. I'm using that HMA binder course theoretical equation where I have my length in feet, my width in feet, my thickness in inches, times my assumed density, 112 pounds per square yard inch. Here I have my conversions. I get 2,264.6 tons. Now I have to make my adjustment for the density of this mix, my C factor adjustment. The stated GMB was 2.360. got my units conversion constant, and here's my 112 that was assumed in design. I get 0.986. Don't forget that third decimal place. I take my C factor times my theoretical, C factor times my theoretical, and now I have my new adjusted plan or theoretical quantity, 2232.9 tons. That's the new theoretical. So my max pay would be this new theoretical times 103%, or 1.03. Tells me 2,299.9 tons is the maximum I can pay for. And the contractor delivered us 2,310 tons. So not too much, but the contractor is exceeding the maximum amount. On page F17, I know this is a little small for you, but we're going to key in on this bottom right corner of that bituminous paving daily record, where we're looking at our theoretical and we're calculating for surface course our C factor. Here is this box blown up a little bit more. This person was tricky and integrated their C factor into the equation, but we've broken it out for you down here into the steps that you would take. The theoretical, actual width in feet, length in feet, density term, 112 pounds per square yard inch, actual thickness or plan thickness, 1.5 inches. Got my units conversions here. 880.3 tons would be the theoretical amount. Now we need to adjust for the density, and we're using a GMB of 2.450. I should really have that next digit. So there's my GMB term right there, times my unit conversion, the 112 pounds per square yard inch that was assumed. I get a C factor of 1.0237. I take this C factor times my theoretical. So I got my theoretical times my C, tells me 901.2 tons would be the adjusted theoretical. That should be the amount that I'm looking for on my job. You can see that number here. They delivered and placed by tickets, 920.6 tons. I want to do my yield check on my HMA for the entire day. I take delivered divided by the theoretical times 100, tells me I got 102% yield. It's over 100. I'm happy. We'll get up at 4 a.m. and do it tomorrow. Page F18 is the backside, or the second page of your bituminous paving record. And here we've indicated our stations where we've checked running yield checks throughout the day, and we're doing pretty good. We had over 102% for each of our yield checks that we documented here.